Hey students, this is a Chapter 2 bonus lesson on arcs and sectors. You're going to learn how to find the length of an arc and how to find the area of a sector. Now, just a little quick definition. An arc is part of the outside of a circle, and a sector is the area of the circle. So this is considered a sector where it's shaded in there, the shaded area. We're going to learn how to find both of those. So let's start with finding the length of an arc. And it all relates to the portion of the arc that we're trying to find. And that portion is given by the number of degrees. So in general, we can say that the length of an arc is equal to the number of degrees, where n is the number of degrees, divided by 360, because there's 360 degrees in a circle, times circumference. And just as a reminder, circumference is equal to diameter times pi, or the circumference is equal to 2 times the radius times pi. Use either of those formulas. So for illustration purposes, I just drew a whole circle with a dotted line. But for this problem, all we want to know is how long that line is from A to B. And it relates to this angle 60 degrees. Now that means that we're turning 60 degrees out of the total, which is 360. So what we need to do is just find the portion of the arc. And one thing we can do is first find the circumference, so the total, which would be the dotted line all the way around. And to do that, we just do diameter times pi, or 2 times the radius. So we're given the radius, so let's just write this down. The circumference is equal to 2 times 7.3 times pi. All right, so, and for now, I'm just going to write this in terms of pi, which means I'm not going to approximate it. I'm just going to write 2 times 7.3 is 14.6 times pi, because we have to do a little bit more work. Now remember, that's the whole entire dotted line. So all of this, and I only want the blue part of this arc. So that's how long that whole thing is. Now to get the portion that I want, I need to use my angle. And I need to do 60 out of 360. And I'm just going to simplify that as much as I can. That's 636 or 1/6. And according to the formula, I need to take that times the circumference. So I'm going to take 1/6 times 14.6 pi. And I can simplify that, and that's the length of my arc, AB. I can simplify that as much as possible. If I do 14.6 times 1/6, I get 2.43 repeating times pi. Now that's in terms of pi. If I approximate that to the nearest, and since this is to the nearest tenth, I'm going to round it to the nearest tenth, and that's equal to about 7.6 centimeters. And that's how you find the length of an arc. Now let's find the area of an arc. And again, I want to remind you that we're actually finding part of a whole circle. So I'm going to do D here. So if I was trying to find the area of this whole circle, I would just use the formula pi r squared. And in this case, our radius is 32. But I just want this part of it. And I'm going to get that part by, again, using the number of degrees, which is 110, out of the total number of degrees of a circle, which is 360. I'm just going to simplify that as much as I can. That's 1136. And then I need to multiply that by my area, which is 32 pi. 32 squared is 1024. And I need to multiply that by pi. But in terms of pi, I'm just going to leave it there for now, because I need to use that here, times 1024 pi. And I'm going to show you how I do this on a calculator. So I have this fraction 1136, 11, and I'm going to use the divide sign to represent that fraction. Now I want to multiply that by 1024 pi, so I'm going to do times 1024. I'm going to leave the pi out for now. And I'm just going to simplify that as much as I can, but not change it to a decimal yet. And the way I can do that is go to math, and number 1 is fraction. And if I enter with that, I will get the fraction as a common fraction, so lowest terms, 2,816 ninths. And then that is times pi. So in terms of pi, so if I'm going to leave it exact, that's my answer. Now I'm going to approximate that. And so to the nearest, since this is a whole number, I'm going to go to the nearest whole number. So I multiply that times pi. And on my calculator, I would just do times, use the pi. And that gives me 982.96, which is to the nearest whole number, 983. And so, and then I need to label that, since it's area, cubic centimeters, or squared centimeters. All right, I'm going to do a couple more problems here. Again, we're going to use the formulas. In these, we're given the length of the arc, so we know how long this arc is. We want to find out what the number of degrees of the angle is, so n degrees. And our formula says that if we take n divided by 360 times the circumference of the circle, and the circumference this time would be 24 pi, because I need to do 12 times 2 to get the diameter, that will equal the length of the arc, which is 12.56. So I'm just going to work backwards. I'm going to do n is equal to 12.56 times 360, because it's divided by 360 in the problem, and then divide that by 24 pi. And I'll show you how I do that on the calculator. So I'm going to do 12.56 times 360, enter. Now I want to divide that by 24 pi. And to make sure I divide by that whole denominator, I'm going to use parentheses here and put the pi symbol right in there in the parentheses, hit enter, and I get 59.96, which is about 60 degrees. So, and so n is 60, so the angle measurement is 60 degrees. Let's do one more problem here for area. And again, we're given the area. So, and we can use our formula again. Our area is equal to n divided by 360 times the area of the circle, which is pi r squared. And I can replace the area. We're given the area as 120. So we'll substitute 120 for the area. We don't know the angle. We do know the radius is 14. And then I'll just simplify that. And I get, well, actually, we can work backwards right now. I'm going to do, to get n, I'm going to do 120 times 360 and divide that by 14 squared times pi. 14 squared is 196 pi. So I'm just going to do that on my calculator. 120 times 36 divided by 196 pi. Sorry about that. So 120 times 360, enter, divided by 1, I need parentheses here again, 196 pi, parentheses, enter. So I get about 70, we'll round that to 70 degrees. All right, and that's the end of the lesson. We'll practice some of those in class next time I see you.